We present Seg&Struct, the interplay between part segmentation and structure inference for 3D shape parsing. There are mainly two approaches for 3D shape parsing: part segmentation and structure inference. Part segmentation decomposes the shape geometry into a set of part instances. On the other hand, structure inference abstracts the shape as a hierarchical structure, including part bounding boxes and part relationships such as symmetry and adjacency. While both directions have been extensively explored, still there are challenges for them. Part segmentation has been mostly performed without structural priors that tell the plausibility of the segmentation, producing noisy regions between part segments. For structure inference, it has been typically conducted with an encoder-decoder network, which fails to predict the accurate output from the raw shape geometry. To overcome these challenges, we propose Seg&Struct, a supervised learning framework leveraging the interplay between part segmentation and structure inference. By helping each other, our key idea is to build a synergy between two tasks in an integrated framework in a bi-directional way. In the first stage, we perform segmentation-driven structure inference. We first parse an input geometry into part segments, using a pre-trained segmentation network, and encode them as a set of leaf node features. Next, we construct feature hierarchy in a bottom-up manner, based on the pre-defined tree structure in StructureNet. Here, we have two kinds of priors, the segmentation prior and the hierarchy prior, which greatly help the following decoding step. Next, the following structure decoder recursively propagates the root feature to leaf nodes, and predicts the part bounding boxes and part relations between two nodes under the same parent node. Our decoder takes advantage of an explicit guidance, given by the established associations between the part regions and part nodes in the previous stage. This gives us a strong supervision for decoding step, by enabling the network to know the exact part region to which the part node is related. As a second stage, we perform segmentation refinement by merging two conflicting part segments, examined from predicted structure. Here, we found that this task largely depends on the structural context, since the local information does not suffice to decide which part has to be merged to other one. Given predicted structure from earlier stage, we first detect candidate parts to be merged by examining confusions of part boundaries. Next, we encode candidate part segment into features, and aggregate them with the structure-aware node features from the decoding step. Using these features, we then compute a merge feature for each merge case, an order variant feature vector to predict merge operation from the candidate node to its target node. Similar to candidate features, we update the merge feature by aggregating it with the root feature from the encoding step, which provides the global context across the structure. Finally, we calculate merge scores for each candidate pair and process the merge operation for the case with a high score. By exploiting both supervisions, our framework utilizes a synergy between segmentation and structure through the interplay between them. Moreover, this interplay between two tasks further improves the quality of each task again, while making a loop. For our experiments, we use two datasets: PartNet for part segmentation, and StructureNet for structure inference. To focus on diverse and complex shapes, we test our method on chair, table, and storage furniture categories. For structure inference, we compare our method with two baselines. The first one directly encodes an input shape into a latent vector without segmentation, and decode it using the decoder of StructureNet. The second one uses our structure encoder, while not leveraging the point-to-part associations used in our decoding step. In qualitative evaluations on structure inference, ours clearly outperforms the other baselines as following. We also illustrate the qualitative results of our proposed interplay between part segmentation and structure as following. Please note that the red arrow points the confusion of part boundaries. Thanks for watching. For more details, please visit our website.